Hello and welcome to the 340 Club. In this video, we're looking at how to compare fractions. And we're looking at three cases. First, when they have the same numerator. Second, same denominator. And third, when there are no similarities. So let's begin. The first case we'll look at is when they have the same numerator, right? So we'll start with this example, 17 over 23. And we are comparing that to 17 over 25. So when they have the same numerator, you compare their denominators. The one with the smaller denominator is a bigger fraction. So we are comparing 23 to 25. 23 is smaller than 25, which actually means 17 over 23 is larger than 17 over 25. So when they have the same numerator, you compare the denominators, and the one with the smaller denominator is actually the bigger fraction. Let's look at another example. In this example, we are comparing 11 over 34 to 22 over 50. It doesn't look like they have the same numerators, right? But I can simplify 22 over 50 to 11 over 25. So now we are comparing 11 over 34 to 11 over 25. So same numerator, compare the denominators. The one with the smaller denominator is the bigger fraction. So comparing 34 to 25, 25 is smaller than 34, which means 11 over 25 is bigger than 11 over 34. So that's how to compare fractions when they have the same numerators, right? The next one is when they have the same denominators. So same denominator, let's start with this example. 15 over 40 versus 19 over 40, which is bigger, right? So 15 over 40 or 19 over 40, which is bigger. So once we have the same denominators, the one with the bigger numerator is the bigger fraction, right? So 19 is clearly bigger than 15, right? So 19 over 40 is obviously bigger than 15 over 40, right? So just compare the numerators. The one with the bigger numerator is the bigger fraction. Let's look at another example. So 11 over 25 and 9 over 40. They don't seem to have the same denominators, but you can quickly realize that 25 and 20 are both factors of 100. So I can bump both of them up to something over 100, and then we can easily compare them. So I can multiply 11 over 25 by 4 over 4, and then get 44 over 50, 44 over 100, sorry, and multiply 9 over 20 by 5 over 5, and get 45 over 100. Now we can compare these two. They are the same denominators, so the one with the bigger numerator is a bigger fraction. 45 is clearly bigger than 44, so 45 over 100 is bigger than 44 over 100. The next thing we'll look at is when there are no similarities in both the numerator side and the denominator side, right? So our first example is 5 over 8, and we are comparing that to 9 over 14. 5 over 8, comparing that to 9 over 14. So what you do in this case is that you multiply across. You take the denominator of one fraction and multiply with the numerator of the other fraction, right? So I'm going to take 14 and multiply it with 5 and write the result on the 5 side, right? So 14 times 5, and that's 70. Then I take 8, multiply with 9, and write the result on the 9 side. So 8 times 9, and that's 72. And now it's just like the previous example. 72 is bigger than 70, so 9 over 14 is bigger than 5 over 8. So let's look at another example. 9 over 11 and 4 over 5, which is bigger? So take the denominator of one fraction and multiply with the numerator of the other fraction and write the result on the numerator side, right? So 5 times 9, that's 45, write it there. 11 times 4, that's 44, write it there, right? So 45 is bigger than 44. So 9 over 11 is bigger than 4 over 5. It's as simple as that, right? Let's look at another example under this. So in this example, I'm comparing 8 over 12 to 7 over 10, which is bigger. So take the denominator of one fraction and multiply with the numerator of the other fraction and write the answer on the numerator side. So 10 times 8, that's 80, and 12 times 7, that's 84. So 84 is clearly bigger than 80, so 7 over 10 is bigger than 8 over 12. So that's it. It's as simple as that. Let's do one more example on this. Let's compare 11 over 13 to 6 over 7. Once again, take the numerator of one fraction and multiply with the denominator of one fraction, multiply the numerator of the other fraction. So I'm going to do 7 times 11. You get 77, right on that side. 13 times 6, you get 78, right on that side. 78 is bigger than 77. So we can conclude 6 over 7 is bigger than 11 over 13. Now, why does this work? So let's look at why this works. So we have 11 over 13 compared to 6 over 7, right? So to compare two fractions, you either have to make the numerators the same or make the denominators the same, right? So those are the first two cases we looked at. Make the numerators the same or make the denominators the same. The simpler one is to make the denominators the same. It makes it easier to compare. So that's what we'll do right here, right? So let's multiply 11 over 13 by 7 times 7, 7 over 7, sorry. And then 6 over 7 by 13 over 13. So what happens is that we have 77 over 13 times 7, and then 78 over 13 times 7. So now they have the same denominators, so all we have to do is compare the numerators. So we are comparing 78 to 77. The bigger one is 78, so that's the bigger fraction. So what we did in previously is a simplified version of this. So 11 over 13 to 6 over 7. We know we are going to get the same denominators every time. So no need to calculate for the denominators, just calculate for the numerators. So just do 7 times 11, which is going to appear at the top, and 13 times 6, which is going to appear on the top of the other one, right? They'll both have 13 times 7 as the denominator, sorry. So no need to calculate that. Just calculate the numerators and you're done. And that's the reason behind this algorithm, and that's why it always works, right? So 78 is bigger than 77,